Hey guys, okay, next conversion is if you look at your top of your page that has the turtle, you've got volume to volume, and actually we're also going to turn that into volume to mass. It's just like what we've been doing. Again, we did mole to mole, then we did mass to mass, but now we're going to throw in volume, which you guys already know from a couple weeks ago, that 1 mole of any gas at STP, which is standard temperature and pressure. You really don't have to worry about it, but in case you're interested, that is 0 degrees Celsius and 1 atmosphere at pressure, which is actually sea level. But again, don't worry about that. That's just setting the stage in which you can do these problems. And we're going to assume everything's at STP. But anytime you have an STP, 1 mole of any gas is equal to 22.4 liters of that gas. So let's say we have a gas problem. Not that kind. But we have hydrogen, oxygen, and water vapor, and hydrogen and oxygen combine to form water vapor. So this is actually an equation that we've seen a lot of. I'm not going to put in the states of matter because my writing's awful and I can't fit it in. But hydrogen gas, H2, remember, always, and oxygen, O2, good. And then we have water vapor. So in this case, not balanced. You guys know what to do. 2 there and a 2 here. All right, there's our recipe. So now what we can use, we can actually go to the next problem part, which says how many liters of water vapor are formed when you have 4.85 liters of hydrogen are burned in the presence of oxygen. Now notice it just says it doesn't give us an amount of oxygen. It really doesn't. So we can just kind of like just make that go away. We don't even have to worry about it. Okay? So what you're concerned with, again, what are we trying to get to? Liters of water vapor. What's given to us? 4.85 liters of hydrogen. Okay, so we're going to set this up the exact same way, except for instead of molar masses, we have liters, which makes it really easy because they're going to cancel. You'll see in a second. But we have 4.85 liters of hydrogen, and we are trying to get to liters of water vapor. And now our first step is to go from liters to moles. Well, using this, how many liters are in a mole? 22.4. So we're going to put that on the bottom. We have been putting the molar mass on the bottom, but not this time. This time we're going to put liters on the bottom. Now it's the exact same thing we have been doing. It's our recipe step. And what is it? Well, we have moles of hydrogen. That's what we're working with here, is hydrogen to water vapor. It's a 2 to 2. 2 moles of hydrogen, 2 moles of water vapor. Sorry, my writing's so bad. And now our last step is, okay, we are now moles of hydrogen to moles of water. That's where we want to go, but we want liters. So what's our very last step? To go from moles of water to liters, which is, of course, 22.4. And this is where I said where a lot of this is going to get real easy on these problems because so much of the stuff cancels. First of all, 2 over 2 cancels, yeah? 22.4 also cancels with 22.4. Why? One is on top, one is on the bottom. So when it comes down to it, 4.85, that's what you start with, times 1 times 1 times 1 divided by 1 times 1 times 1 is 4.85 liters. So that is it for this one. It's just the volume to volume problems are so easy because, again, half the time the 22.4 and the 22.4 all cancel out, and you're really just going to have to worry about that step. So go ahead and try, I think it's the first, let's see, actually it's 1 through 5 on the volume to volume problems. Go ahead and try those out, and then we're going to mix it all up. Okay, bye.